Alright, in this video we're going to do the next couple questions from our AP Calculus Readiness Review assessment. So this next set of questions is all about, again, end behavior. And so what we're looking at here, instead of being given an actual equation for the function, we're just given a graph. And we're given a graph separately of the numerator and the denominator. So here it's h of x is equal to f of x over g of x. And here we have the graph of f and g. They tell us that g is linear and that f is polynomial. And I should have been a little bit more clear here. I think I am in the next one, that not only is f polynomial, but it's degree 3. So when I look at this graph and I say, okay, well, this is degree 3 and this is degree 1, it's linear, I can come back and I can kind of think about my rules for rational functions and end behavior, but I can also just say, okay, this is going to keep going to negative infinity. This is also going to go to negative infinity, but this one is going to get there a lot faster. This one shoots down really, really quick. This one's going to take a while to get there. It's not even a very steep slope. So if I have this f of x and it's a really big negative number, and then I have this g of x, which is a big negative number, but not as big. I've got the same idea as we had in the previous video with the e to the x, where I have this f of x number is just so much bigger than that g of x number when we're talking about the output there. So that means that the output's going to keep getting larger. A big number divided by a pretty big but smaller number will still be a big number. A million divided by 10, it got smaller, but it's still a big number. And in this case, both those outputs are negative. So it's a negative big number divided by a negative not as big number. That means we're going to have a positive large number for our output. So this would be positive infinity. And the same thing is going to happen on the other side as our inputs go towards positive infinity. F of x is going to get big, and it's going to get bigger a lot faster than g of x. You can see it already. Look at when the input is 5. When the input here is 5, the output for f is already at 7, where here we're not even at 1. And that's just going to continue to be the case here. So you have a big positive number divided by a not as big positive number. That's another big positive number. Okay. Now, the next couple questions, we just go through the same idea, but the way that we're combining the functions has changed. So this is, again, a quotient, but we've flipped the numerator and the denominator, g of x divided by f of x. So now, when I go to the left, as x is approaching negative infinity, you've got a negative number here. It's a growing negative number, so it's getting a big negative number, but you're dividing it by a much bigger negative number. So first of all, you have a negative divided by a negative, so your output's going to be positive. But then if you think about your fraction, a relatively smaller number divided by a relatively larger number. You have, right here you can see it, 1, 2, 3, divided by 4, 5, about 6. So that output is already a half. And that's just going to continue to happen here. This degree 3 is just going to get bigger and bigger and bigger and bigger and bigger, but be negative. This one will continue to get bigger and be negative, but not as big. So you're going to have 0 as the output. You can also think about it in terms of the degrees. You have a degree 1 on top and a degree 3 on the bottom. The rules tell you that's going to go to 0, but it's helpful if we understand why that rule is the rule. So this is 0. Then on the other side, once again, you have what will be both positive, but a relatively small number divided by a relatively large number. Here we have, maybe about a half divided by 7. Well, that's 1/14. That's a really small number already, and it's just going to continue to be small. So that's, again, 0. moving on to the next way we're going to combine these functions. Now we're going to multiply them. And so going to the left, as x approaches negative infinity, you have a number that's going to be negative but getting bigger. Negative and getting bigger. And when I say a big negative number, I mean like negative a million. Okay, now technically we know that negative a million is a smaller number than negative 1. But I mean a number that is big in absolute value and happens to be negative. When I multiply these two things together, of course, the first thing that happens, a negative times a negative, is going to be a positive. But then it's just going to get bigger. 3 times 6 is 18. And then it's negative 3 times negative 6 is negative 18. So that's just going to get bigger and bigger and bigger in that, and then be positive because they're both negative numbers here. So it's going to get really big. On the other side, same idea. They're both going to get large and be positive. A large positive times a large positive is an even larger positive. So that's, again, infinity. Now, we can think about it in terms of our rules. If f of x is, again, degree 3 times a linear degree 1, well, that's going to give me a degree 4. We know that the two ends have to go in the same direction. And in this case, they're both positive. It's a positive linear and a positive degree 3, so it's going to stay positive, so both ends will go towards positive infinity. Okay. Again, the rules are nice, but we want to make sure we understand why those rules work the way they do. Now we're adding things. Let's start with the rules this time. If you have a degree 3 and you add a degree 1, that doesn't turn it into a degree 4. It's still a degree 1. You're just going to combine some it's still a degree 3. You're just going to combine some like terms there. You're not going to change the overall degree. So adding this linear function to our degree 3 function, which again, I know it doesn't say degree 3 up here, but it was supposed to. It says it in number 6 there. So adding this onto there, it's just going to make a number that's big already even bigger. So this is going to continue to go towards positive infinity, and that's on the right-hand side. And on the left-hand side, when our x's go towards negative infinity, my end behavior here is a getting bigger negative number plus a getting bigger negative number. So I add those two things together and I should get a large negative number. Now remember, just like on the first set of problems, all those assumptions we were making about getting rid of the -3 or the +4 or the -1, whatever it happened to be, I honestly don't remember. That was only something we could do when the number was large, when the input number was large. The same thing is true here. We're only talking about the end behavior. So we're only adding the end behavior of these functions together. We're not talking about what happens in the middle. So this, and nothing really on the screen is large enough to be what would be considered a large number, an end behavior. But because we know that this one is linear and this one is degree 3, we can take what we're given here and we know what the rest of the graph will look like. Okay. So that's our second part of the video. There will be several more.